Okay, welcome back once again. Today's lesson is about solving simultaneous equations using a graphical method. So we've been solving simultaneous equations algebraically using the elimination process, where we try and get two variables to have the same coefficient and we eliminate one letter, x's and y's, and then we go back and work out the other one. And we're doing pretty well at that. But I want to give you another method for solving simultaneous equations that uses a graph. That's going to do two things. Firstly, it's going to reinforce your understanding of how graphs work, a little bit of revision, a little bit of a reminder. But it's also going to give us the tools to deal with simultaneous equations that aren't linear. So if we had a squared in the equation, we don't know how to solve that algebraically yet, but we could do it with a graphical method. Exactly the same method as the one we're about to see here. So I'm going to pick two equations. I'm going to go with y equals 3x minus 4 and y equals 6 minus x. And now I know a lot of you could solve that algebraically and produce a solution like that, but today's lesson is about us doing it graphically. So if I'm going to solve an equation graphically, obviously I'm going to have to draw the graphs. These are both linear graphs. They don't have any squares or anything in them. So for a straight line graph, I need 3 points. 2 points for a line and the third one just to check that you haven't made a mistake. So if I do 3 points, they should all form a nice straight line. I'm going to pick some values. So I'm just going to do the first equation. I'm going to pick some values for x. And work out the corresponding value for y. So I'm going to pick the values -2, 0, and 2. I could pick absolutely any values that I wanted. I'm going to pick those ones. I want to spread it out a little bit, because if you spread it out a little bit, if you've got a bit of a gap between your values, it makes it a little bit easier to draw your graph accurately. If you have them all bunched together, 3 points all very close together, it's not always easy to see where exactly the line goes. So it's always a good idea to spread them out a little bit. Okay, so when x is -2, so just looking at this equation, then y equals 3 times -2 minus 4, which is -6 minus 4, which is -10. When x is 0, we get y is 3 times 0 minus 4, so y is -4. Which shouldn't be a surprise, because we're familiar that the -4 should be the y-intercept. So when x is 0, we get the answer -4. And lastly, when x is 2, we get the answer y equals 3 times 2 minus 4, which is 6 times 4, which is 2. So there's the 3 points that I'm going to plot. I'll have a look at this equation in a second. I'll just deal with the first equation first. We'll come back to that in just a tick. So did I just copy that? I can't remember. Let's copy that across. I've already set up my axes on the other slide. You can see I've spaced out the x-axis a little bit. Let me label them. Spaced out the x-axis a little bit. The y-axis is a little bit more squashed in. Well, that's fine. And here's my table from the other slide. So they're the values I'm going to plot. When x is -2, y is -10, so that's all the way down here. When x is 0, y is -4, so that's there. And when x is 2, y is 2. They're the same for that one. So that's there. So my equation, my line, is going to look like, keep going. Remember, I don't just stop at the 2 points that I've drawn. I need to fill the page. And I'm going to label that equation y equals 3x minus 4. That was the equation of the line. Y equals 3x minus 4. Okay, don't need that again. It's on the other slide. Don't need those either. Let's do the other equation quickly. So again, I can pick values for x and values for y. Again, I'm going to choose 3, and I'm going to choose the same values for x. There's no obligation to choose the same values for x, but I might as well. And I'm going to do these ones in my head. So, looking here, when x is -2, 6, take away -2. If you take away -2, well, it's the same as adding. 6 take away -2 is 6 plus 2 is 8. This one, 6 take away 0 is 6. And when x is 2, 6 take away 2 is 4. So there's the points I'm going to plot. So again, I'm going to group them so I can take them to the other slide. Oops, no, that's not what I want to do. Copy, there we go. Drop them on the other slide so that I can plot the points. Stick them there, just trying to find somewhere where they're not in the way. Okay, once again, plot the points. -2, 8 is the first one. Oh, we're in blue. 0, 6 and 2, 4. There's my 3 points. I'm join them up with a straight line. Oh, worked that out wrong. Missed. Let's try that again. About there. That's better. Okay, spot on. Let's lose the table. Don't need that anymore. So I've drawn my 2 lines. I haven't even remotely thought about what it means to solve these 2 equations simultaneously. Let's label this one quickly. Y equals 6 minus x. So I've got my 2 equations, 3x plus 4 down here, and 6 minus x over here, and they're represented by the 2 lines. Well, if we're solving them simultaneously, we're looking for when are both equations true. What value of x and what value of y works for both equations? Just going to neaten this up a little bit. Well, where's the point that works for both equations? It's this point here. Let's choose a different colour. You can probably guess where it's going to be. For both points, it's this one here. I'm not going to draw over the top of it because I want to try and be as accurate as I can. It's the intersection point, it's the solution. And just like when you were solving them algebraically, I want a value for x and a value for y. Well, what's the value for x? Well, it looks to me like the value for x here is 2.5. And the value for y, let's get a straight line on that. Let's see what colour straight lines I've got. Nice green one. So there's the value for x. Value for y looks to be, it's close to 3.5 maybe. And this is not a precise method of solving equations. It's worth emphasizing that. It's not a precise method. You can make it more precise by doing 2 things. Firstly, you'll have graph paper when you do it, so your squares will be much smaller. Obviously, for clarity, my squares are much bigger. And secondly, if you fill your page when you're drawing a graph, so you make it really big, then that will also allow you to be more accurate. So by doing those two things, you'll probably be able to get a greater accuracy than what I've got there. Okay, I'm going to leave that there. As ever, if you have any questions about what we've done today, please bring them. But if not, we'll get started straight off with plotting some graphs and solving them. See you on Friday.